the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
By WSP, who are the joint sponsors of the Hugo News Sustainability Seminar Series. Their Senior Vice President, Steven Salom from CEOE, a good friend of me and a very good friend of the program. Steve Eggett is here with us. So he will introduce Tom Abdallah, who will be a speaker today and will talk about sustainable mass transit. Steve?
Okay. Hey, well, thanks, Dibs. And, definitely personally, and I know WSP feels, it's a great program, and we're glad to be able to sponsor all the good work that you're doing there at Stevens and Hoboken. It's also really my privilege to introduce colleague, good friend, mentor, and definitely one of the leaders in this kind of field of sustainability, Tom Abdallah. For those of you who don't know him, he's a vice president and a chief environmental engineer at MTA Construction and Development. Again, been one of the leaders of leading all of MTA's, billion-dollar plus projects, making sure they're as sustainable as possible and in compliance with the telephone book of regulations that each of them is subject to. And not only has Tom been a pioneer there, but he's a professor at Columbia, has guest spoke at Stevens, City College of New York, and also, I don't know, in his spare time, whenever that is, also authored a book, Sustainable Transportation, which is it's really a great book and something I recommend to everybody who's wanting to learn more about the field and things that they can do to make a difference. So with that, I'd like to hand it over to Tom.
Thank you, Steve. Thank you, Dibs. Appreciate it. So, as Steve said, I authored a book, actually two, if you count first and second edition, called Sustainable Mass Transit. First book came out in 2017, and the second edition came out last year. So just a little bit about myself. I started at MTA 1987 as an assistant environmental engineer. Well, first I should say, get it out of the way early. I did go to Rutgers University for chemical engineering and graduated in 1985. I did a little work as an environmental technician and then got the job at the MTA as an assistant environmental engineer. I became a full engineer, a project engineer, a principal engineer, a construction manager. Then I became chief environmental engineer in 2004. I became a professor at Columbia in 2013. I've been an assistant vice president, deputy vice president, and now a vice president of the MTA Construction and Development Agency, which, if you're familiar with New York City's MTA, we have the New York metropolitan region. We have the New York City Transit, subways and buses. We have the Long Island Railroad, Metro North, bridges and tunnels. And around 4 years ago, we kind of took all of the engineering and construction and put them into one agency that deals with all of the sister agencies. Most of my career was with the New York City Transit, the subways and the buses, but my role is expanded to include the commuter rails and the bridges and tunnels. So, as Steve mentioned, I wrote a book in 2017. I actually wrote it in 2016. The theme of the book really is that in the first paragraph of the book, that mass transit is inherently sustainable in its practice and has great opportunities to be more sustainable in its operation. Henceforth, sustainable mass transit. So, by and large, mass transit is the best sustainable solutions a city, a state can employ. And what I've done over 38 years, almost 38 years, 37 and a half, coming on 38, make it more sustainable. And so I tried to put almost everything I've done in the first book. And that includes, work in sustainability and National Environmental Policy Act, all the eclectic environmental topics, including waste management, hazardous waste, asbestos, lead. Everything is in there, including environmental management systems. So we'll talk about a little bit, mostly we're going to talk about the sustainability elements, but there's a lot in the book, and we'll get to that as we go along. But first, there's a little primer on mass transit that we're actually going to talk about mostly today. Again, there are other modes of mass transit, including ferries and other modes, but we're really going to talk about generally, the trains and the buses. So we'll start with the transit system, the train system. There is 350 miles of tunnel underneath the city of New York, which moves millions of people every day. I like to show this photo because it shows one of the most important aspects of the infrastructure, the mass transit, subway infrastructure, and that's the switching system. You see that little X there, a couple of little X's along the way. This is what allows trains to travel from one track to the other, or go from a local to an express to local, and I have some photos there. I'm going to show you very interesting about the signaling and switching system. The signaling system is an important opportunity to choreograph moving trains 24 hours a day, 7 days a week. The transit system does have entrances and exits. That's across the street from where I'm working right now on the right, the Bowling Green. And we have below ground subway stations. This is the Whitehall Street station. It's actually underneath the building I'm in right now at 2 Broadway. And the train does come from below ground to above ground. This is the one train coming from from a subway. And we also, in addition to the 350 miles of subway tunnel, we have approximately 70 miles of elevated subway track, which is generally above roadways here in New York City. We also have above ground stations. This is the 18th Avenue station in Brooklyn. Just happens to be my home station when I take the train to get home. In addition to subway and elevated, we have what's generally referred to as at grade, or slightly below grade. We have several miles of transit like this. In addition to showing that additional type of transit infrastructure, I do also want to emphasize here in New York City, we have to deal with all 4 seasons when it comes to engineering and operations and maintenance as well. As you can see here, this photo of the Franklin Avenue shuttle, you see the fall, the time period we're in right now, where you have to deal with the leaves that fall onto the track. And and that can become problematic because as trains slow up, come to a break, if leaves are on the track, they can actually create what's called flat spots on the wheel, which could create noise, which could infuriate those people that are living very much right adjacent to the system. And that's another reason why I want to show this photo. You see that our system approximately is adjacent to about 3 million people throughout the city. Right on top of it, next to it, you can reach out and touch it. One other reason why I like to show this photo, because I have another photo in the wintertime. So we have to deal with the winter events. And this is approximately at the same location with the shuttle. And we also have to remember when we engineer, when we design and basically when we design, we have to make sure we have to worry about the in the wintertime, the ice and the compression, the rails, and then of course as it gets warmer, we have to worry about the expansion. So we have to always design with the 4 seasons in mind here in New York City. So some other infrastructure here in the metropolitan area. This is the Metro North going up adjacent to the Hudson River. So I like to show these photos because it shows just how in close proximity that our infrastructure is to potential rising sea levels. We also have infrastructure that goes right over the water. This is a bridge. This is one of our significant bridges, and it carries the A train over the Jamaica Bay, and that is called the Jamaica Swing Bridge. So when the boats that want to come by that have too high a mast, that need to get if it can't fit under the bridge, that bridge actually swings out and creates an opportunity for maritime traffic to go, and it's kind of a very interesting infrastructure that we have. And I also like to show that there's a lot of infrastructure in real estate that most people don't see. All right, these are depictions of train storage yards, and so when the trains are not on the road, they need to be laid up somewhere. And this is in the left side in Queens, in Flushing, and then the New York City Transit, and then on the right side, which you see where the Empire State Building is, that is a Long Island Railroad storage yard. So there's an immense amount of property that I like to call it ancillary facilities, ancillary property that goes with the actual running of the transit system, not just the infrastructure that you see, the stations and the trains, but the actual ancillary stuff that many people don't see. So now we'll talk about buses. We see we have about 5,800 buses here in the metropolitan area. The bus on the right side, well, the kind of normal looking one on the left side, and then the one on the right side is called an articulated bus. Many people like to refer to those buses as accordions because it looks like they have like a little accordion, but it doesn't work as an accordion. Accordion, goes up like this, but this is more of a hinge. So you get with one engine, you pretty much have about 1.5, maybe even 1.75 size of a bus that we can also utilize to get more people on the bus, but still only using one engine. And this is their buses have a home. This is a bus depot, typical bus depot, and we have about 25 bus depots, and this is where buses get fueled when they come in from the outside, when they finish their run. They get fueled, they're maintained. All of the buses and subway cars are done by the MTA's own maintenance force, which is kind of unusual. Many transit agencies around the world and around the country actually farm out this part. But in New York City here, we have 70,000 people, and many of them are dedicated to the maintenance of both buses and subway cars. And also, as the bus comes in from the outside, we give it a bath, we give it a shower. It goes through a bus washer, and it's not just to ensure that the bus is as beautiful, as clean, but keep in mind that when buses and cars generally, as they travel outside, they get dirt winds up on them, and what we try to do is we try to take the dirt off so it doesn't go into an engine. If you ever, after a long period of time, opened up your car trunk, and if you haven't opened it up in a long time, you'll find a lot of debris has built up underneath your hood. And especially at this time of year, you'll open it up and you'll see like leaves and stuff. You want to keep that stuff out of the engine so that you can keep the engine as preserved as long as possible. So now that we've talked a little bit about the actual vehicles, facilities, and infrastructure, we'll get into the actual relevance of mass transit. So this is a typical day here in New York City. You have jam-packed cars on the highways and streets, and then you have amazing amounts of traffic. Even still to this day, there's just a daily traffic jam here in New York City. And if all of those people in those cars were to find their way into the subway or the train that's on the elevated train there, if you take people out of the, especially single-driven cars, and you move them into multi-passenger vehicles, this is what makes mass transit the most sustainable opportunity for cities to become more sustainable. New York City is the most sustainable city in America because even half of the people in the city don't even own a car. They don't even need a car if you don't want one. You can travel very well on the public transit system. And like I said, about 50% of the people don't necessarily need a car. I mean, the closest city statistics from years and years ago, so I don't want to quote anything too much today, but San Francisco is about 15% of its citizens don't own a car. And also here in New York City, very different from other cities in America, the predominant emissions is from buildings, whereas in most cities across America, it is the transportation, which of course includes cars. So that's what makes mass transit the most sustainable solution. And again, when I say we, mass transit has its carbon footprint. And we rely on electricity to run the trains, we rely on diesel fuel to run the buses. So we do have a significant, even though it's really good, it's still a significant amount. So what I've kind of done over the last 3.5 decades is try to make it more sustainable. And so some of these sustainable solutions that we're going to talk about today, and there's many more in the book, but we'll talk about electric buses and regenerative braking, energy storage, renewable energy. I'm going to show how we've incorporated some renewable energy into our capital construction projects, green infrastructure, air pollution control, LEED buildings. We do have facilities. We have LEED facilities, recycling, natural lighting, and LEDs, light emitting diodes. Light emitting diodes are a much more energy efficient type of lighting. And actually about 20 years ago, you see this photo here, you see those signals right there, the two sets of signals with the red lights. Those are actually LEDs. We went to LED lighting for signals about 20 years ago, and we're continuing to utilize LED lighting on stations, station platforms, tunnel lighting, and also on the train car. You see the N train there is lit with LED lighting. So we have LED lights that adorn the train car. Another reason why I like to show this photo, remember I was telling you about the signaling and switching system that is paramount to moving, 5 million to 6 million people every day, 24 hours a day, 7 days a week, in a very rapid fashion. This photo actually shows one train that's actually on all three tracks at the same time. So you see it going from the left screen to the right screen. It's on the two local tracks and then the express track in the middle. And then there's one train right behind it. So the signaling system prevents any kind of, catastrophe with ensuring that trains can only move in certain blocks when the signaling system is green for them, and then it'll turn red. So it's kind of a very important operation, the signaling and switching system. If you ever are in New York City and you do happen to ever get stuck on the train, it's not moving, 95% of the time it's a signaling or a switching system that it needs to be fixed. So we'll talk a little bit about electric buses now. Like I said, we have over 5,000 buses here in the MTA. We'll go into a little history. We are obviously, buses run generally on diesel fuel. We have some buses that run on compressed natural gas, which again is okay. But it's still a fossil fuel. It's in some places they call it clean energy. It's cleaner than diesel. But in 1996, we actually started to employ hybrid buses. So these are dual. You have a battery and you have a diesel engine at the same time. So we've been dealing with kind of battery operated trains going back, almost 30 years. But we're moving toward absolute electric battery operated trains and buses. And what you see there is the charging infrastructure, two different types of charging infrastructure. This is on the right side. You see this is on the roof of the Michael J. Quill bus depot. Those are the electric chargers that will charge a bus overnight. So once it's finished its day and it gets parked, it gets charged overnight. On the left side there, that upside down L is what's called en route fueling, and there are not too many of them. And I would like to say that although electric buses, we have a goal of zero emission buses by 2040, and in about 6 weeks or so we're going to be in 2025. We got a long way to go. We have about 250 electric buses with 250 on order. Though every 5 years we're going to be purchasing electric buses. Hopefully by 2040 we will have a full-fledged electric bus fleet. However, there are many challenges along the way, and the E part of an electric bus is the actual electric bus, and that's not so easy either. But really the idea is, where are we going to get the energy to juice up all these buses? And then of course, where are you going to put the charging infrastructure? If you equate this with electric vehicles, cars, it's the same issue. The electric car is the easy part, but where are you going to get the infrastructure is the important part. Is there enough energy in the city? Is there enough electricity in the city to charge cars? And then of course, with many, especially here in the city, they want to electrify every building. So where are we going to get all this energy? So this is the challenge for the next generations to come. Where are we going to get this electricity to have all of these electric buses? And I also like to say that maybe we should vow not necessarily to be all electric, but to be zero emissions, because I think there might be other, opportunities, maybe in hydrogen and other opportunities for zero emissions as we get further along. So this is me. I asked them if I could charge a bus, and they said sure, but just watch your fingers. So I was able to charge a bus, and then so we have these rooftop parking charging infrastructure. And then there on the left side, this is in the actual bus depot where buses are charged. And so, you know, you can charge a bus in a couple of different ways, kind of in sort of like mimic the gasoline, you know, dispenser, where you plug in the electric, you know, the dispenser in the back end, kind of like a car. But you can also, remember I was telling you about that upside down L, the on route marker. You can also charge buses from the top. Generally, most of the batteries, although there are some on the side, are on the top part of the bus. So there's what's a pantograph can fall out of that upside down L and then charge a bus from the top. Now, again, going back to my statement earlier about the charging infrastructure being the biggest challenge here, I just want to show you that this is, you know, this is from the other side, that big, on the lower right picture, that giant box there, that is a charging infrastructure. So that charges that on-route charger to allow the battery to be recharged. So you see that there's a lot of space that is needed. This is just for one charger. So the movement toward electric vehicles is so many layers. It's the energy, it's the space, it's the coordination with the DOT, and then of course coordination with electrical entities like Con Edison. So it's not just, it takes an entire region of entities to move toward an entire fleet of electric vehicles, and in this case electric buses. So that's the biggest thing with the buses. For the trains, the biggest energy efficiency potential lies in something called regenerative braking. And this is the theory here is that if two trains are traveling in the same direction and one train is braking, and so the energy from a train comes from what's called the third rail, and that third rail is live with electricity. So when the motor person presses the pedal or demands energy, the energy comes from the third rail into the train car. When a train brakes, it actually, with regenerative braking, one of the ways it slows the train down is to reverse the polarity of the engine from a motor to a generator. Because instead of demanding energy from a third rail, we're actually doing the reverse, pushing it back into the third rail. Now, it will work if there's another accelerating train on the same line in general proximity. So as you see here in figure 1, you have a braking train ahead and then an accelerating train behind. So that regen, they call it, can go from the braking train to the third rail, and then it can be used by the accelerating train, and you get some energy efficiency this way. Now, here in New York City, the trains are pretty close together, so it kind of can work. It works mostly in the peak hour when the trains are, you know, within 2 or 3 minutes of each other. But even in some non-peak hours, sometimes a train on the same line is just, you know, too far away, or it's just not there. And then what happens is the regen will go back into the braking train and get dissipated as heat. So in other systems, and you know, we're kind of also working on this here at MTA, but say in Philadelphia at the SEPTA system, they have a energy storage, a battery, so that when the regen goes into the third rail, if there isn't an accelerating train, the energy could actually go into an energy storage system, a battery. And then when a train actually comes by, it can actually use the train's regen that was stored in the energy storage system as part of the energy for the train. And it's such a success in Philadelphia that they're actually using energy storage systems in some lines in lieu of substations. And you see here a substation is where the energy from the power grid, the energy comes from the power grid into a substation, and then from the substation, it goes into the third rail. And from what I understood from the chief engineer at Philadelphia, they also use the energy storage system to help stabilize the voltage. So from what I'm understanding from this operation is you want voltage to be stable, and the energy storage system can also help the power grid keep stable, because if it's too high or too low, you could short circuit the train. Now, in other areas, especially in places called Bilbao, Spain, and in Vienna, they're actually taking their regen from the braking train, and they're putting in what's called a reversible substation. So instead of if there isn't a train, accelerating behind it, it can actually go into a reversible substation and then back into the power grid. Very much like excess from a solar panel, when there's enough energy and the solar panel can, instead of powering wherever it's powering, it can actually reverse the meter, so to speak, reverse metering. So this is very similar. So I was in Bilbao, Spain in 2008, and they were actually getting 30-35% energy efficiency. And then as I was researching for my book, I found that in Vienna they were doing the same thing. So this is kind of like a big game changer thing that, again, you need to work. The transit agency engineers need to work with the entity that supplies the energy, like Con Ed, in order to make this happen. So there's a lot of challenges here, but it seems to be working in places like Vienna. And then, it's funny, the regenerative braking, it's also on the electric vehicles. Like if you have a Prius or electric vehicle of the car, the same thing. When my brother has a Prius, so when I'm in the car with him, and as he's braking, it actually shows on the dashboard how regenerative braking from a car, the regen from the Prius, is actually also going back to into the battery of the car. Same thing with the buses. The buses are equipped with regenerative braking as well. And from what I understand, elevators can also utilize the theories of regenerative braking on in their operations. So one thing I should mention, while my book is called Sustainable Mass Transit, the sustainability elements and solutions can be used across the board. It doesn't have to be transit systems, and it could also be other types of fleets. So all of while the book is centered around mass transit agencies, it can be utilized in almost many different entities. And again, it's really an A to Z on sustainability. So just a couple of other things, I wanted to also, in combination, you see this here. This is my building here at 2 Broadway, and you see a lot of this. This is the bike sharing. All right, so there's one of the most sustainable ways of transporting yourself around town is on a bike. And if you go to Europe and Asia, you see a lot more biking. But I went on a trip to Europe, and I was saying, wow, people bike everywhere. They bike to work. They bike with a suit on. A woman would bike in a dress. Biking is big, and in other places. But when I got back here to New York City, I actually noticed there's a lot of biking going on around here as well. And one of the bike sharing, best practices is when we have our bike sharing, the city bike here in New York, surrounding our station. So you can use the subway system, the train station, and then get if you're part of the city bike, and you can use the city bike, because in many stations, especially in Manhattan and the Bronx, not so much Brooklyn and Queens, but Manhattan and the Bronx, there are many outlets, areas where the city bike has sort of combined with the transit system. If you go to Asia, in fact, there was 2 case studies I did in my book. I did 20 case studies in my book from transit systems around the world, including Europe and Asia. And bike sharing is big. Bike sharing is much bigger in outside of America, but we're catching up here. And then the other thing here is, just while we're here on the subject, I'm here in my office here in 2 Broadway. That's my office right there on the corner. I have the corner office. Actually, if I look out my window, I can see the Wall Street Bull. And so you notice my shades are up because I have a nice corner office. I have the most sustainable office in the building, and it was just happened to be this way, but it turned out. And it's also an excellent place to watch any parade that comes by the Canyon of Heroes, if you happen to be in the area. So other projects that we've worked on here in New York City, this is the Stillwell Terminal, the largest northeastern above ground subway terminal here. And it's a rooftop canopy that is a solar panel. In addition to being a solar panel, it also it's thin film solar encased in 2 panes of glass, and it also allows natural lighting as well. There's nothing like this anywhere. One of the couple of things, this is the Coney Island area. Let me see if I can go back. So you see the Coney Island, you see the parachute jump. This is an old photo. This is a very iconic part of New York City, the Coney Island amusement park and beach area. And so the design was in a kind of a motif of an arcade, but it also has a feel of a European train terminal. I remember going from Germany to Italy, and the train we were taking, which went about 200 miles an hour, it stopped in Basel, Switzerland for a change, and the actual terminal looked a lot like what I see here. So we have kind of a double motif of an arcade and a European train terminal. Another where we use solar. This is a thin film solar on the canopy of an above ground station in Jackson Heights, Queens. So you see this kind of thin film. Thin film is a little easier to deal with. You don't get the efficiencies that you do with a thicker type of solar panel, but look what you can do with it. You can put it on a canopy. We at some point figured that we had about 18 million square feet of canopy we can actually put solar panels on. Boston's a line doing a lot of canopies, in Chicago they're putting a lot of this solar on their canopy structure. Another use of solar, more practical use, but a kind of a microcosm of sustainability. Here's a solar panel that is feeding what we call a lubrication house. And the lubrication house works this way. When a train goes around a curve, it detects the train before the curve and squirts a little biodegradable grease that modifies the friction around the curve. So, the wheels of the train are always straight, but the infrastructure, the track, actually curves. So when those straight wheels go around a curve, it can kind of screech. And one of my jobs here at MTA is to investigate where people have found some of our system to be a little bit noisier. So on these curves, on the elevated structures, and in other parts of the infrastructure here in New York City, wherever there's curvature in the track, it could cause a noise issue. Now the theory here is that we have a solar panel which is powering a battery which is in this lubrication house. So in a lot of ways, the future of sustainability is the combination of renewable energy, solar and wind, coupled with energy storage. I say this tongue in cheek, but it's not always sunny and it's not always windy. But at some point, we need to store that energy from the sun and the wind into energy storage systems to ensure sustainable outcomes. But we do have some, generally traditional types of solar. This is the Corona maintenance shop in Queens, where we have just kind of like that thicker film of solar, where you have a little bit more space. The solar panels are a semiconductor, and when the sunshine hits the panel, it excites the electrons, and those electrons move a little bit, and so we capture the movement of those electrons in a kind of a circuit, and then that's where we derive electricity from solar panels. So remember the thinner film solar from the Jackson Heights canopy, that has less room for the electrons to get excited. That's why a more traditional solar panel like you see here gets a little bit more efficiency, because there's a little bit more area for the electrons to move. And we applied those solar panels to our first lead building. This is our Corona maintenance shop in Queens. You see this is an old photo. This goes back a long way. That's when Shea Stadium was still there. If you're a baseball fan, you'll know that Shea Stadium no longer exists, and in that parking lot there is where Citi Field is, where the Mets play. So this particular facility, again, the first industrial transportation facility to achieve LEED certification. So you see solar panels, you see a reflective roof. When a roof is reflective, when the ultraviolet rays of the sun hit the rooftop, if it's reflective, those ultraviolet rays will go back into the atmosphere. But if the sunshine hits a darker surface, that surface is going to heat up, like you see in that parking lot area. And then when that surface heats up, then waves, shorter waves, will go back into the atmosphere. And that's actually what's captured by greenhouse gases like carbon dioxide. That's what actually creates the global warming, the greenhouse gas effect, and the global warming. So you see, some really fine features here. One of the interesting parts, you see that this building was angled, kind of in a strange angle. And what we did is we wanted to take advantage of the prevailing direction of the wind when we designed this. So this is the interior of this shop. And so as the weather gets warmer, the louvers there on the right side, they open up automatically after a certain temperature, and then they start allowing the natural direction of the wind to come in to the facility, and actually comes in, and it kind of moves, cooler air kind of moves the warmer air up and out. I don't have a photo of it, but on the top side of the left side of this photo are louvers up there. So a lot of the sustainable solutions that we've talked about here really go back to the most basic science of things like heat rises, energy is neither created or destroyed, it's just kind of moved around. If you talk about the regenerative braking, so a lot of sustainable solutions are sort of foundational in fourth grade science, which still works today. So it's not imperative if you want a job in sustainability. You don't necessarily have to be a scientist or an engineer. It kind of helps if you have basic science principles, and that's one of the chapters in my book. I talk about what is the necessity to be an environmental sustainability champion, and what do you need to know in addition to policies and things. You do need to have a certain amount of understanding of some basic science. Here is a building, a very sustainable building. It has our first green roof. I will talk about green roofs in a couple of projects from here. But this building is sustainable in a couple of different ways. One, it's a signal crew quarter. So people who are fixing those signals along the right of way, they actually show up to this building first. And this building was built on top of a platform that looked very much like the platform on the top side of that building. And it also utilized a canopy structure that looked just like the one that you see there. So one of the first hallmarks of a sustainable building is to, use what's there as opposed to, using, virgin materials. So in this case, we used a foundation that was already there and a canopy structure that was already there. And we actually, you see here in this photo, we actually used the canopy's old columns to hold up the roof of this particular building. So this was an architectural, challenge, and so they saved the steel. They saved foundation. Now you also see there a skylight. So in this case, we want the free energy of the sunlight, but we don't want the heat that goes with it. So we actually coat this glass with a low E coating so that we get the light, but not the heat. And we also use that same principle on one of our stations. This is the 96th Street station on the 1 and the 2-3 line, where you switch, you either go local from the local 1 to the express 2 and 3. And we actually designed the rehab of this station with that same type of low E coating glass. And we actually were able to get sunshine down on the platform of the transit system. Anytime you can create a more clearer, brighter, vision unimpaired type of atmosphere, especially here in New York City, very, very, very good. And we, as I mentioned, we're in the process. This is an old photo, but we're in the process of moving toward LED lighting. And from what I'm told from the people in stations, is that LED lighting, anyway, any kind of way you can brighten up your system is good for the closed circuit TV when it comes to a security issue. And also, we have, as part of this project, we also rehabilitated and created some open space. And I like to call the seams of our infrastructure and MTA's infrastructure with the city's infrastructure, with the park infrastructure, the streets. And this is a lot of places where we can create some open space. We have some green infrastructure there, shade from the trees. This is right in the middle of Broadway. And the final project that we're going to talk about today, this is the Mother Clara Hale Bus Depot. This is our showcase sustainability project. It's about 10 years old. And so unfortunately, we broke the very first rule that I was telling you about, try to keep all the old structure there. Unfortunately, this older building was too small, and we generally had to recycle everything. We had to demolish everything. So we did the next best thing. We recycled over 99% of the concrete, the brick, steel. We took all of the any unused piece of equipment, doors, and we brought them onto other depots. So we did a great job of recycling. We built the building with a green roof, about the 4th or 5th largest green roof here in New York City. The biggest one I understand is at Javits Center. Second may be at the Kaufman Astoria Studios. The third one may be the Barclays Center. And I'm not sure if there's a one between us, but let's just go for we're either 4th or 5th. And green roofs do a great job of actually creating a larger amount of insulation on top of a roof. Remember, heat rises, so you want to, the rooftop insulation is one of the best ways to keep a building energy efficient. Absorbs rainwater, absorbs carbon dioxide, but it also absorbs particles that are floating in the atmosphere. So those particles that are floating in the atmosphere from the incomplete combustion of diesel and gasoline, and even in a lot of ways, some ways, CNG. So those particles, less than PM 2.5 particles, which you can't see, at some point are going to float and they're going to land on the blades of grass of this green roof. Green roofs are not lawns. They're actually engineered soil in trays, and they actually will want to absorb rainwater and particles. So when the particles stick to the blades of grass of this green roof, it'll actually flush those particles into the soil, and you actually can remove a lot of the floating particles by utilizing green infrastructure, and in this case, green roofs, if you're part of a LEED project, you'll know that LEED gives a lot of points in many different areas for green roofs. And then the other aspect here, you see these big giant boxes. Those are what's called heat recovery units, and they're actually heat exchangers. So as you have to change air 4 times an hour inside of this bus depot. So as air is coming in, let's say in the wintertime, when cold air is coming into the bus depot, warmer air already in the depot will come out and sort of heat exchange it and actually help warm the cooler air coming in, and also provides a lot of energy efficiency. If you're familiar with the LEED process, energy is one of the bigger amounts of points you can get. And for this particular building, from an energy point of view, we got all the points available. And so remember, I told you green roofs do a great job of absorbing rainwater. So when the green roof is saturated with rain, actually it also actually will help when it gets saturated. Because it's connected with trays, the water will flow through the tray flow system and into drains that you see there, and will drain into a 50,000 gallon tank. Also, we have a white reflective roof, and any rainwater that lands on that will also go into this 50,000 gallon tank. And then we use that water to wash the buses. So in effect, any droplet of rainwater that drops onto this large city block size depot is not going to go into the sewer system. And so it's going to help prevent flooding. And then when we do wash the buses, we also have a reclamation system where we recycle the water. One of the innovations here we have is something called the solar wall. The solar wall is very practical. It's just a metal wall with thousands of holes in it on the southern side of the building. And so it's a wintertime thing as well. When the sun heats the metal up, we bring air through these holes in this wall, and we actually save about 2 or 3% of the energy by just utilizing air that went through a heated up metal wall. We only have that on the southern side. So 2 or 3%, over the long haul, it's going to give you some energy efficiencies, and it's the most practical thing we have. It's just a metal wall. On the other sides of the depot, we don't have that, only on the southern side where it makes sense. And then finally, here is the finished product. You see the green roof, you see the heat recovery units, and now you also see the gold LEED certification, which we were very proud to be the first inner city bus depot to achieve LEED certification. We beat out LA Metro by about 6 months. They're our partners on the other side of the coast, and they do a great job of sustainability. Like I said, my book has 20 case studies, including case studies from around America, Philadelphia, Chicago, BART in San Francisco, LA Metro, and many others. And there's a separate chapter on environmental management systems, which could be the topic of another presentation. And so finally, just one thing about I put in a few future endeavors, and one thing I think could be a possibility of the future, taking our 2 main sustainability solutions and combining them into one. We got the regenerative braking into an energy storage system, and then we actually add a bus. We have the bus be charged by the energy storage system. So trains and buses working together to become more sustainable. And just a couple of final things. Been very fortunate, been on Channel 13, Channel 7, a couple of NPR radio things. The big microphone in my face there on the top right, that's from an NPR interview. So I've been very fortunate. I love to talk about sustainability. Been on several podcasts, including 4 times I've appeared on the Environmental Professionals Radio. And if you are into environmental sustainability, they have about 60 podcasts, which you can utilize where you get your podcasts. And I've been very fortunate to be a guest on several of those. But one of my favorite things that I've ever done I was on a History Channel Modern Marvels program, where I was in one of those, guest experts on transportation related. So if you do have Modern Marvels and or on your TV or your cable, but you could also go on their website. Season 19, episode 3. It's a great episode hosted by Adam Richman, who was it's a Brooklynite like me, and he was also the host of one of my favorite shows on cable called Man vs. Food. And I didn't get to meet him, but kind of an interesting, addition to my career, being on the television show that every once in a while I do check the channels to see if it's being rerun. So finally, as I mentioned, I wrote a book in 2017, and in 2023 I came out with a second edition. Just keep this in mind. There is, in addition to wonderful sustainable things and case studies, I also talked about mass transit's response to the COVID pandemic, which was heroic. And I also, a chapter in there, chapter 3, if I remember correctly, is completely about sustainability professionals. So if you're a sustainability professional, you might want to check that chapter out. And thank you very much. I'll take any questions or whatever the next step is here.
Hey, that was an excellent presentation. Thanks, Tom.